If you have ever taken your kid shopping, you have seen this exact scene play out at the top of every escalator in the world. A tiny plastic shoe gets dangerously close to the yellow grooved teeth at the bottom of the moving staircase, and a parent yanks the child away like they just avoided a woodchipper, while everyone behind them rolls their eyes and shuffles past. It looks like paranoid parenting, but escalator manufacturers, transit safety inspectors, and the engineers who maintain these machines will tell you that those yellow combs really do bite, and they bite thousands of people every single year. In fact, the escalator is the only machine in the entire building that is legally required to try to hurt you on purpose, because the moving rubber handrail is deliberately engineered to travel slightly faster than the metal steps underneath it. That sounds like a manufacturing defect, but it is a calculated safety feature, and if you have ever felt yourself leaning forward while riding up, your body was quietly proving that the machine is working exactly as designed. To understand why the most boring machine in the mall is secretly one of the cleverest pieces of mechanical engineering ever installed, we have to look past the shiny metal and into the truss hiding underneath your feet. An escalator is not a staircase that moves. It is a conveyor belt that pretends to be a staircase, and the entire machine lives inside one giant steel box called the truss. The truss is a welded lattice of steel channels that spans the gap between the upper and lower floors, and it carries the entire weight of the steps, the chain drives, the motor, and every passenger standing on it at once. Hidden inside that truss are two endless loops of precision steel roller chains running around geared drive sprockets at each end, and every single step is attached to those chains, riding on wheels that roll along fixed steel tracks. Here's the clever part. Each step actually rides on 4 small wheels, but the front set and the back set travel on 2 completely separate track systems. On the flat approach at the bottom and top of the escalator, both tracks run at the same level, so each step stays flat and lines up perfectly with the floor to let you step on without tripping. But as the step travels into the incline section, the back track drops lower than the front track, which forces the step to pivot upward and lock into a flat staircase formation with its neighbors, creating those level steps you actually stand on. At the top of the incline, the front track curves upward while the back track stays low, and each step tips forward, flattening out again to slide smoothly through the comb plates before disappearing underneath the landing plate. The steps themselves are typically die-cast aluminum, about 16 inches deep, with cleated surfaces and yellow edge strips, and they are engineered to hold enormous loads, because a single escalator step is rated to carry 300 pounds or more, and a typical commercial unit moves 6,000 to 9,000 people per hour, 20 hours a day, for decades. Now for the part almost nobody knows, the handrail speed trick. The rubber handrail and the metal steps are driven by the same motor but through separate drives, and safety codes require the handrail to move at exactly the same speed as the steps or slightly faster, never slower. If the handrail moved slower than the steps, passengers gripping it would be dragged backward relative to their feet, and hundreds of people would topple over every day in every mall on Earth. Making it slightly faster means your hand arrives at the top just before your feet do, pulling your body naturally upright and forward into your step-off. That tiny speed difference, usually under 1%, is why you sometimes unconsciously lean forward near the top of an escalator without realizing why. Your hand got there first, and your spine followed the rail. Engineers call it handrail lead, and it is one of the most elegant pieces of passive safety engineering hidden in plain sight, because it works on every single passenger without them ever knowing a machine just adjusted their balance. At each landing, the moving steps slide under a fixed metal plate edged with a comb of yellow or black teeth called the comb plate. Those teeth mesh perfectly into the cleats on the step surface, so a shoe or a coat can never get dragged down into the gap between the moving step and the stationary floor. When the comb teeth are new, this system works flawlessly, but escalators in busy stations run millions of miles of step travel, and as steps wear, flex, and develop side-to-side play in their guides, the gaps at the comb grow just wide enough to swallow soft things. That is the dark truth behind the escalator accident statistics. Soft rubber shoes, loose shoelaces, flowing dresses, and drawstrings get pulled into that comb gap, and the step drags them underneath the landing plate with hundreds of pounds of force. Bare feet are banned on escalators in many countries for exactly this reason, and in Japan, where an entire generation grew up wearing soft canvas shoes, escalator accidents injure thousands of people every year, mostly small children and the elderly. The yellow teeth are not a warning decoration. They are a sacrificial wear part that gets replaced on a schedule because they are slowly eating shoes forever. But the comb plate is only a plastic teeth problem compared to what happens when an escalator actually catches fire. And the worst escalator disaster in history taught engineers a lesson written in 31 deaths. In November 19, 1987, a London Underground station called King's Cross St. Pancras had a wooden escalator running up from the ticket halls to the platforms, and a discarded cigarette match fell through the gap between the steps and landed on the running tracks underneath. For decades, cleaners had allowed fluff, dust, paper scraps, and grease to build up inside the machine truss because nobody thought the space under the steps mattered. The match smoldered in that debris, and the fire crept along the wooden step sides in near total darkness, with passengers walking right over it, feeling warmth through their shoes and smelling smoke, but seeing no flames. Then the fire reached the 45-degree incline, and the entire trench under the steps acted exactly like a chimney laid on its side, funneling fresh air directly into the burning channel. Within seconds, the fire did something fire scientists had never witnessed before, a phenomenon now called the trench effect. Superheated burning gases shot up the inclined trench as a roaring jet, erupting out of the top of the escalator like a flamethrower and igniting the wooden ticket hall above in under 90 seconds. 31 people died in that ticket hall, and the entire global escalator industry was rewritten almost overnight. Wooden steps and wooden balustrades were banned forever, running tracks were sealed and made fire-resistant, automatic sprinklers and smoke detection were mandated inside the machine spaces, and debris buildup under escalators became a citable code violation in every developed country on Earth. Modern escalators are now packed with safety systems that would have made that disaster impossible. Every step has a sagging step sensor that detects a broken chain or a step running out of track and stops the machine instantly. Missing step detectors watch each step as it rounds the curve, and if one is missing or misaligned, the escalator shuts down before passengers feel a jolt. Skirt brushes along the sides of the steps are not there to shine your shoes. They exist because the deadliest place on an escalator is the narrow gap between the moving step and the stationary side panel, where a shoelace, a jacket, or a curious child's hand can get dragged into the machine, so the soft brushes tickle your foot away from the danger zone before it can enter. The comb plates themselves are spring-loaded, and if something hard jams between the teeth, the entire comb assembly can retract and pop backward, instantly triggering an emergency stop that cuts power to the motor and slams the service brake onto the drive shaft. Under the handrail, broken handrail sensors monitor the rubber loop continuously, because a snapped handrail whipping through a crowded station would be catastrophic. And at the drive machine, an overspeed governor does for the escalator exactly what it does for your elevator, monitoring step speed and cutting power the moment the machine runs away. That last point is the final myth to kill. People treat escalators and elevators like the same vertical transport family, but mechanically they are opposites. An elevator is a suspended cab that can never freefall because of counterweights, cable redundancy, and wedge safeties. An escalator has no counterweight, no cables holding it up, and no cab. It is a chain drive, and its entire safety philosophy is built around one principle: stop the chain and break the machine the instant anything goes wrong. The escalator cannot drop you like an elevator, but it can grab you like a machine. And every safety device on it exists because engineers know exactly which parts of your body the machine wants to eat. The next time you step onto one of those moving staircases, take a half second to look down at the yellow comb teeth sliding under your feet, feel the handrail pulling slightly ahead of your steps, and remember that you are standing on a conveyor belt wearing a disguise, running on the same basic principle as the assembly line at a factory, moving 6,000 people an hour through a machine that is quietly working to stay one step ahead of hurting you. It has no equal in the building for moving that many humans that efficiently, and after what happened at King's Cross, the entire world agreed that the most boring machine in the building would never be allowed to be careless again.